Hey calculus class, today we're going to talk about topic 65, strategy for testing any series. So first we're going to summarize basically a possible strategy, but it's not a go tool, must do it in a certain order or anything like that. With series, you just have to be able to identify what test you need, and that is the hardest thing to do. So in addition to the flowchart that we've been filling out, here are some helpful guidelines to help you determine if a series converges or diverges. So 1, does the nth term approach 0 as n approaches infinity? If not, the divergent test implies the series diverges. 2, is the series one of the special types, geometric, telescoping, p-series, or alternating series? 3, can the integral test, ratio test, or root test be applied? 4, can the series be compared favorably to one of the special types? And the familiar series in the comparison tests will usually be either a p-series or a geometric series, and use absolute convergence and the comparison test when you have a trig series or with some alternating series. All right, so now we're going to go through some examples. And in the following examples, we're not going to work out any details. All I want us to do is just simply indicate which test we should use. So here's our first series where the sequence is n minus 1 over 2n plus 1. So now we would want to use the test of divergence, because if I was to take the limit as n approaches infinity, I would get 1/2, which doesn't equal 0. Therefore, this series would diverge. In this second series, we have a algebraic function of n, so the a sub n is something algebraic, and we can compare the series with a p-series. We should use the limit comparison test, where our familiar series is the square root of n cubed over 3n cubed. And then this would be simplified down so that we can see the p-series a little bit more. And we would be comparing it with 1 over 3n to the 3/2. This next series, we should notice that if we were to rewrite it as an integral, an improper integral in terms of x, this integral is easily evaluated by using u substitution. So therefore we could use the integral test. Another possibility, if we wanted to, was to use the ratio test. This next series, you should notice that we have a -1 here. So this is an alternating series, so therefore we'd want to use the alternating series test. Our next series, we have a factorial. And since we have a factorial, we would want to use the ratio test. And this next series, you should notice that this series is closely related to the geometric series of 1 over 3 to the n, so therefore we could use the comparison test. All right. The rest of the examples are sample AP Calculus BC multiple choice questions. I'm not going to go through how to get the answers on the video. We will go through how to get the answers in class tomorrow. So what I want you to do is pause the video and go ahead and work out the next 4 multiple choice questions on your own. And then once you're ready, I will tell you the correct answers. But in class tomorrow, we'll go over why those are the correct answers. All right, let's see how we did. 7 is A, 8 is D, 9 is D, and 10 is A. Well, I hope you've enjoyed this quick video, and I'll see you in class tomorrow where we will continue practicing tests for series. Have a good night.